Bum 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 bum
I love it.
That's our first, man. What language are we talking about? Ukrainian.
That was the Ukrainian national anthem.
Oh, look at that.
First international song. I love it.
Yeah.
All right, perfect. Carlito.
Manny.
We've got another podcast, and we've got two very special guests. On my left, I have
Orest
from
Polar Bear Geothermal Systems.
And on my right, I have
My name is Roman and I'm also with Polar Bear.
perfect. So we are going to be talking about geothermal heating. How do we call this? Geothermal heating, cooling?
Yes, it's both of those, but more specifically, we're here to talk about water source geothermal using water source heat pumps.
I'm excited.
I can't wait.
But I've got a question for you guys before we begin.
Dum dum
Let's get
dum.
Can you guys tell me when was geothermal first discovered and what country, if you can, tell me the city?
Geneva. You're wrong.
That's not from my information. Geneva? What year?
It was in the 80s.
No, it was in like
Sorry,
1842.
800.
You guys
Yeah.
are both. This is 1904. An Italian scientist, Piero Gino, whatever his name is, in Tuscany. In Tuscany.
I've recently read an article where they talk about how they used the lake in Geneva as for the first water source heat pump.
Are the Italians taking the credit here?
Well,
What's going
hang on
on?
a second. Geothermal can be both, right? It can be heat extracted or cold extracted from the ground without water, right? It
You
could
can
be a
use
different
lake,
type
or
of.
you can use the ground.
That's
but
right.
You're still using the first time the water source heat pump was used was in a lake in Geneva.
By whom?
I don't remember the name of this gentleman.
Well,
The
then
Italian
we're
guy.
gonna have to stick with the facts.
It could have been, they border Italy. It could have been an Italian using
been.
that Lake Geneva.
Okay, so the idea is that it was actually first used in the U.S. in 1922.
It's been
We don't know.
around.
I'm just sharing information that
It's
I
crazy
found.
how this stuff has been around for such a long time, and so many people have no idea what it is.
Well, it's really funny because there's a third and final point attached to this. That when did it become popular in North America? There was a huge global crisis to actually act on this.
I would say
You guys were not born.
30 years ago.
No, a little longer. 1973 during the oil embargo. So once that happened, all of a sudden the world started working together to try to figure out renewable sources, and geothermal became popular again.
That makes sense.
Okay,
sense.
so
Excellent,
that's our
Manny.
opening question. That's
Excellent.
all I want to say. But now let's get into Polar Bear.
I met this gentleman. His name is Denis Campbell at the home show. This man has been manufacturing heat pumps for the last 30 years. He's been building these systems, installing these systems. He's now moved on to commercial projects. Most recent one being a 4-story building, 60,000 square feet per story. They use 15-ton water source heat pumps. They have 18 of them, and those are connected to 73 boreholes in the parking lot that are 730 feet deep.
Wow.
And there is no gas whatsoever in this building.
The whole building is a retrofit. They got rid of all the rooftop units on the roof. The only thing that uses natural gas in the building now is a kitchen range. One kitchen range in their
In the banquet hall.
in the banquet hall.
That's amazing.
I want to get into all this stuff, but okay, so just for our listeners' sake that are not too familiar, because I'm actually one of them, I only know certain things about geothermal that are probably incorrect. What exactly is geothermal? You guys explain the layman's version of what geothermal is.
I'm gonna take it from here because
Take it.
I actually know less than Roman. I'm gonna give Roman's the guy here. He's the genius behind all this.
Okay.
And he's closely being mentored by Denis, our president.
Nice.
So the president of Polar Bear is Denis Campbell.
Okay.
He's been doing it for a long time, and then he found the universe put us together, and now we're learning under him. It's been just over a year now. We're not here to be the best or the professionals or the know-it-alls. We're learning ourselves, and we're here to also spread the word to educate everyone in the construction biz about this, because you know what, net zero is coming.
Yes.
And if you're a better builder, you read articles, you read books, and you know about this. What is geothermal in layman's terms? we are taking heat and moving it to another place.
You're taking heat from where?
Let's say you're taking heat from a building and you're putting it into the ground. And you can take heat from the ground and put it into a building.
What does Geo stand for? It's the Earth. The Earth absorbs the sun energy, and it's stored 6 feet underneath. The temperature is stable all year round. It never freezes 6 feet
Doesn't
under.
matter. 6 foot under, we pass the
Never.
frost line. We have a stable temperature.
So
What
we're
is that
we're-
temperature?
It's here in Canada. It's about 50 Fahrenheit.
I was understanding it was 60 for geothermal, but I guess
These
it
systems
varies.
will work in solid ice. It's not about the temperature of the Earth. It's about being able to take away energy. So even if there's ice, we can still lower the temperature of the ice by taking energy away.
So you're drilling a hole into the earth, and you guys were saying with this particular building, they had drilled 600, 700 feet?
730 feet.
730 feet they drilled down. Now, what determines the depth that you drill?
It's not about the depth. It's about the surface area of the pipe that you lay in there.
Got it.
Because the building is so big, they needed so many of these holes. Commercial building, they don't have the horizontal space to do this. They have to go down. If you have the horizontal space all day, you could lay fields of this stuff. It'll still work.
But vertical is better than horizontal, right? Because you can put too much heat into the ground and then not be able to take that back out of the ground, or is it about spacing it?
That can happen, and you need to plan for that. There's such thing as a heat rejection. You could plan for this happening in the future, and then if it starts to become an issue, you can pull the heat and put it elsewhere.
Orest, you said that you drill a hole and you're taking the heat from the building and putting it into the ground, and vice versa.
Yes.
I'm lost right now. So if it's the winter time,
Yeah.
there's heat in the ground,
Yes.
enough to heat the structure,
Yes.
more than enough to heat the structure.
Yes.
What are you taking out of water? You're taking water, right?
You mean the solution in the ground?
Yeah. What is it? What's going?
It's an alcohol solution. It has isopropyl in there.
And then you're using the energy of the length of the mass of the pipe or whatever it's in the ground. Is it a pipe? It's a pipe.
Yes.
It's a high density polyethylene pipe.
Fusion welded.
Yeah, they're usually in rows.
Big rolls of it. There's high density, medium, and low density. You use high density for geothermal.
Okay, so in Canada, a lot of places we can't go vertical in many places because of stone. A lot of times people will go horizontal. So they'll go under the ground like 8 or 10 feet, and then there'll just be rows and rows of it interconnected.
Most of the time, that's the way it's done, but it's not really a problem. If you have a professional driller, they'll go through stone. The main company for geothermal drilling in the city, Geosource, they have over 10 rigs right now, and they're booked for the next 2 years.
Is that affordable to do it that way?
For commercial buildings, it makes absolute sense because there's payback period of like 5 to 7 years. And this is a building most people plan to own for many, many decades. And they're going to see so much savings in the long run.
See, that's what I was taught, like in the beginning of my construction days, is that it takes 20, 25 years for a payback on a residential platform.
It may
That's
even
not
never. It may
true.
even never pay back.
That's what I heard too. Also.
Okay, on a residential.
On residential. Look, we have to be very clear here. In this conversation, we're not going to be talking about a home on Spadina and Queen Street, for
course,
example.
yeah.
You know, you're not going to. You can vertical drill and install a heat pump in there, but you're really going to have to pay a lot of money and really want that.
And those people exist. I've seen it. I've been in houses, tiny houses in the city, and they have vertical drilling in their parking, in their driveway. They got 3 holes in their driveway, and they're pulling energy.
It's good for them. Where Polar Bear has really excelled is outside the city, Caledon, where your heating is either electric or propane.
Okay, so what does this cost compared to using a traditional way of heating a building structure, like a commercial? What is it? I mean, how, are we twice, 3 times, 4 times? How much?
You mean utility-wise? How much you're paying?
Not utility. I want to factor in the initial setup. If you go into a current building, take the same buildings, and you want to set up a traditional boiler, forced air, or whatever it is, compared to a geothermal is more expensive, correct?
It's usually because of the loop. So there's 3 parts to a geothermal system. You have your earth loop. That's your big heat exchanger. That's a big chunk of the cost, and that's usually what puts it over all the other sources of energy. Then you have the heat pump in the middle, and that's connected to your earth loop. And then you have a distribution system within the building. It could be hydronic, it could be forced air, whatever you have. They could use the same distribution system in all those cases. If you have a furnace, you have a boiler, you have a heat pump, it doesn't matter. And you still have the heat pump, it does both. It does all your heating, it does all your cooling. There's triple function systems that can do your pool, it can do your radiant
Driveway.
It can do your forced air. It can do everything. It's all about the heat pump model you get. Maybe it'd be pricey. Maybe you're paying for a $15,000 heat pump, but this thing's there for the next 20, 25 years and it's doing everything. But the big price, the big investment is the loop. And it's going to hurt you in the beginning, but that loop is, if it's good for the first 5 years, chances are it's good for the next 400 years.
It doesn't deteriorate. It won't fall apart.
No.
Nothing at all. Once it's done, it's done.
Yeah.
How expensive can it get to do that loop?
For a house of say 2,000 to 3,000 square feet, it's around 20,000 if it's horizontal, all in with the tie-in and everything.
Just the loop.
Just the loop.
And then you have your
And that's
heat pump.
because you need excavation. You need somebody who knows what they're doing to fuse this properly, to lay it properly.
Okay, so I'm used to, for argument's sake, let's talk resi. 3,500 square foot house, your HVAC package is going to be anywhere from 40,000 around there.
40,000 up, yeah.
New HVAC package with the AC and everything like that. If you were to do a boiler and radiant, it's double, right? And now if you're going to do geothermal, what is it? We're going from 40 to 80 to what?
Learning from Denis, his philosophy and how he got a lot of clients, he sells his geo systems for just a little bit more than a typical HVAC system. He's been proving a point for the last 30 years.
How is he able to do that?
Because, look, the client wants geothermal. That's it. You're not going to stop them. You're not going to argue with them. They're sold. And geothermal clients, they do their research. They've been learning about it on average, they spend 1 to 1.5 years studying this before they begin shopping for a contractor.
Why do people want to use geothermal that already aren't aware of it or know anything about it?
Well, first of all, there's a certain level of comfort that you get with it. It's hard to explain. It's like walking into a house that has radiant heating.
Well, there's a difference. You
There's
can
a
totally
massive
feel
difference.
it.
There's
You
a-
can
there's
feel
a
it in the
difference.
air. You can feel it in the house. It just feels better.
And with a geo house, same thing.
You're getting that benefit.
You get the benefit, and it's also you're using the earth. There's actually something really special when your home is connected to an earth loop.
Okay.
It's grounded.
Totally.
Try the veal.
But at the energy level, okay, we're coming to a point where we're seeing the world changing really fast right now. For the first time in my lifetime, I've never seen the planet shut down. So what I'm leading to is we're gonna have to go green. The planet is slowly failing and not keeping up. It's not able to rejuvenate itself fast enough. Let's just say that. How much energy are we saving? Are we helping it? Is it green?
Yes.
Okay.
Roman, I'll take this one. I'll take this one because on Friday we were doing some heavy research, and we came across a company in Toronto, N-Wave, and they're doing some really cool stuff.
That sounds familiar.
They're located right beside the Sky Dome and the Steam Whistle Factory. They're using a lake loop. We have Lake Ontario.
Yeah.
Okay, we have Lake Ontario, the 5 Great Lakes. We're actually located in a really cool spot in North America. And one of their clients, I believe it's the TD building, they retrofitted. We need to talk about commercial buildings if we want to talk about savings. Because in the home, it just doesn't make sense.
Okay. So let's leave the resi for now.
Especially in
Let's
the
go
city.
commercial.
It makes sense up north.
We got to talk about bigger stuff because then the numbers make sense. The TD Tower retrofitted their cooling system. So they eliminated the cooling system in buildings. They use chillers and cooling towers. It uses a massive amount of electricity and a massive amount of water. By switching it to this lake loop, they said 250 Olympic-sized swimming pools worth of water every year.
Well, because it's not being wasted now, right? Because
Yes.
it's a closed loop, so there's no actual water coming in or out. It's just about cooling it.
Yes.
Taking the heat out of the building, extracting that, making it back to the 50 or 60 degrees, and then bringing it back in to make new energy, right?
Yes.
Okay. Before you move forward, hang on a sec. So what's the website? Because everyone's going to want to check this out. So what is the website?
PolarBearGeo.com.
PolarBearGeo.com.
That's right.
Is there a social handle?
Polar Bear Geo on Instagram.
You got it?
Any other socials?
We have
Our
that
time-
really nice video about the commercial building.
Yeah, you guys sent us the link, which was really cool.
That's on YouTube if people want to check it out.
So you can go to
Our
the-
channel is Polar Bear Geo.
Perfect. And an email?
Info@Polar Bear Geo.
Look at that. Everything's Polar Bear Geo. Polar Bear Geo. All right, perfect.
You don't write a
Well,
song.
it makes sense because at 50 degrees.
Okay, so back to the TD building. They were spending a lot of money on cooling the building, but they only did the geothermal just for cooling, or they're not going to bother doing it for heating?
I'm sure they can use it for both. I'm not going to speak about it too much.
No, you can. Yeah.
I know the cooling details.
I'm just asking the question
Let
because
me put it simply. This company, Enwave, they've contracted with City of Toronto water supply, and they're selling the energy and the domestic water supply coming from the lake to buildings in the downtown core. So the water's there anyway, and it's still flowing wherever it's going to go for domestic use. And they're allowing buildings to pull energy out of it. So they're allowing buildings to connect to it and use it for heating or cooling, whether they have a geothermal system or they want to do a strict cooling directly with the water. They're selling energy in the water.
you guys got to back it up because listen, this is the first podcast that I don't know shit about what we're talking about.
Manny.
I just know it from afar, right? I just know that it's really expensive, and just like you guys confirmed it, I will never see the return, or a client of mine on a resi platform will never see the return. So I never dove into it. I'm not in commercial. I pay attention to
Right. No,
commercial.
you're right. You always say that.
Okay,
But look at people up north, people that don't have natural
that makes a
gas.
lot of sense to do it up there, and I agree with everybody here that we need to be doing things like this, and it should be more economical for the resi. It totally, I complete. Forced air is the dumbest thing I've ever seen in my entire life. Forced air is a North American thing, and it actually sucks. It does. It's a bad system to heat and cool a house. That's my opinion. Okay.
It's affordable.
My point is, I need to be told, okay, you guys need to explain to me, how does the hot or the cold come out of that loop? I need to know, you got cold water from Lake Ontario. It is fucking cold in summertime.
Yes.
You guys heard of air source heat pumps?
No.
Like AC kind of looking.
Okay,
heat
yeah.
pumps?
Yeah.
It's the same idea. Instead of using the air, we're using the water, which is a far better conductor.
So as the water travels through it,
No,
it's
around it.
around it.
So instead of having a condenser outside, you have the loop. The loop is your condenser.
It's like a rad underwater.
Got it. Okay, now I get it.
So it's like submerging a rad. You know how a rad has, corrugations up
Yes.
and down. So basically, either you're going to go vertical or you're going to horizontal, and you're basically putting a rad in cold water, and then you're figuring out how to extract it. Am I right?
Kind of. Okay, Manny. I'm gonna give my
I don't
best
know why
shot.
I'm listening to him.
I'll give it my best shot because when I started learning about this, it was blowing my mind.
Okay.
I was actually getting really frustrated in class.
Okay, go
I
ahead.
I would leave
because that's where I'm at right now,
This
man.
wouldn't let me sleep at night. And I was trying to figure
Here
out
we go.
how the hell, when am I gonna start understanding this?
Okay,
So,
enlighten me, please.
Look, we got to put the money thing aside. Money conversation needs to leave.
Okay.
Forget about the money.
You know
guys.
what? You're right. Some things money shouldn't come first.
what about the blue collar?
No. My point is that some people can't afford to do this, but the people that can and make a difference in the world should.
And we're not a competitor to natural gas. We're not competing with natural gas right now. We're competing with electricity and propane, 100%.
We know
then it makes
electricity
sense.
is evil. Electricity, that's a whole other talk. But if every car was electric, we'd have a big, big problem.
We're still cheaper than natural gas. It's just the installation cost that really
Yes.
hits people. Cheaper on the utility. If you look at a chart of how much you're paying on your utility, you look at a chart of efficiencies and you compare electric, you compare propane, natural gas, oil, everything. Geothermal is going to destroy everything. It is by far the greenest and by far the most efficient.
Okay, so please explain.
Okay, I will continue.
do your best, man. I'll try to absorb it.
Okay, guys.
I'm making notes.
Manny and Carlito. Mr. Pavlovich. I
love him already.
I'm gonna test your knowledge right now. So when you have a traditional forced air system, you have split AC, which is made up of two major components, correct?
Yes,
Which are
the outside compressor or whatever,
Yes,
and
and
the inside
coil.
the
whatever
inside
it is.
coil.
Yeah,
Correct. So the inside coil, it's called the evaporator. It absorbs the heat using the refrigerant inside. So now, what does the outdoor compressor do? What is that big box outside doing?
sucks air in. No, blows air out.
Okay.
Moves
What's
air.
cooling it?
No. You are
It's good. I like this already.
okay. Your refrigerator at home, it's a box.
Yes.
It's a box inside of a box.
Right.
You have a refrigerator inside of a home. What happens? Why is it cold inside the refrigerator?
Because I set it to 2 degrees.
But what happens to the heat? Because there's no such thing as cold, right?
But the heat comes to the back and then it gets dissipated, just
Yeah.
like it would on the outside.
yes. So
Cold is the absence of heat. So you're removing heat.
you're removing heat. You're just moving the heat.
Okay.
And that's how you create energy.
No.
Hold on a sec.
No.
You're
Hold on
getting
a
ahead
sec.
of them. You're getting ahead of them.
So that heat in the back of your fridge, that's the heat from that was inside the fridge. It is now outside the box. You've used the compressor and you've used the refrigeration cycle to remove heat.
I get it.
You're moving heat.
Okay, I get it.
You're removing heat. That's what is cold. What is cold? Cold is lack of heat. So we are extracting heat using refrigerant and moving it to another place. Your air conditioning system, the outside box called the condenser, that thing, if you put your hand on top of it, it's warm, right?
Yeah.
That's your heat from the house being removed. But when you're running an AC here in Toronto, it's 30 degrees Celsius outside. You're trying to cool the refrigerant using hot outside, like you're dumping heat into heat. It's a lot of work. It's difficult. Water source heat pumps and a ground loop, the ground now is how much colder?
And it's consistent.
And it's
lot
consistent.
colder.
So we're taking, and physics 101, heat molecules go where?
I didn't do well in physics 101.
Heat molecules move quick, and they want to move to somewhere where it's cold.
Okay.
Okay, when you open your fridge, why does your mom always yell at you to close the fridge? Because you're allowing heat to go inside or cold to escape.
That's right.
Right?
Okay.
So using a ground loop, we're taking the heat that's inside of a building and we're dumping it into something that's much more relatively colder.
Okay.
So we're using the earth as a heat sink. We're dumping the heat inside, and it just does. The 101 of this all is that it does a much, much better job than a traditional split AC condenser outside or a cooling tower.
I think I got it.
You need to think of the heat pump as a refrigerator. It's a massive refrigerator for your home.
Interesting.
Okay, so let's talk about the 2 seasons. We're in Canada, obviously, so there's hot and cold. So
We just talked about cooling, essentially.
right. So we want to heat a building. Does it work the opposite?
So there's a reversing valve inside a heat pump, and it allows the evaporator and the condenser to switch. So instead of removing energy from the home and dumping it into the earth, on heating, you're removing from the earth and dumping into the home.
Yay!
Yeah. So during the summer, we're pulling all the heat away, and the water's doing all the work. That way, we don't have any mass around our home or in the building, right? And then during the winter, we're gonna take that heat, instead of putting it back into the ground, we're gonna leave it in the building. Is that how we're talking? Because it's still looped in, right? So it's still going back into the ground.
You're confusing me when they tell me one thing and then you say something.
No, I'm trying to figure this out.
I didn't understand what
It's
you said.
This is normal, guys. Wait, this is normal.
I got the
We-
refrigerator
we
thing.
can work through
the
this.
refrigerator thing made sense to me, and the AC made sense to me because I could put those two together. I can open up the door and I can go outside and see all that hot air coming out. I get it. So now I
And
understand.
that
So
entire cycle can be reversed. So
it
instead
could
of
totally be reversed for
so
heating.
instead of removing from inside the fridge and dumping to the outside, you can now collect outside the fridge and use it to heat the fridge.
Mm-hmm.
So you can take the heat outside of the building and you can dump it into the building.
And in the buildings, when you're cooling the buildings, what are you using to move? You're moving air.
Man, you're gonna really be disappointed, but it's still a forced air system.
But it's so much better for one reason. Gas spits out heat at a really high temperature, a gas forced air system.
Okay.
A geothermal system spits out heat at a much lower temperature, and it allows it to become a lot more consistent throughout the home before it shuts off. So it actually gives time for all your walls, all your floors to catch up. With gas, you're going to see a big difference between the floor and the ceiling. With the geothermal system, you're not going to see a difference, and there's no combustion happening in your home.
So let's go back a little, because if we're having problems, I think some other people might.
No. Maybe they won't, man. Dude, I'm not a
People
mechanical
really
guy.
want to learn everything about this. They need to dive deep, and they need to do some
Okay,
research.
so we understand that the water loop system will stay the same in the seasons, we can switch it over. So that all stays the same. And then there's just a switch over from winter to summer.
Did you know you can also use the same heat pump that's heating and cooling your home to do your domestic hot water? And in the summer, it's totally free.
Yeah, guys. Okay, listen to this. A Polar Bear heat pump has something called a de-superheater.
A de-superheater.
De-superheat. It's like a turbo.
Okay. And it heats the water for your
free.
domestic water.
For free.
Because it's already made that
Is
energy.
this a boiler?
So we can heat
Are
it.
you doing a tank? Are you doing a boiler?
No, it's a compressor. It's still
It's an extra little coil before you reach the other big coils. It takes the hottest heat off the compressor right away, cycles it into your tank. So it's a coil that is connected to your tank, in and out, in and out.
I can
And
dumb
it's
it down.
stealing.
I can dumb it down. I can dumb it down, guys.
Let's go.
Listen. So the heat that the system has taken from your house, it now needs to get sent into the ground. But before you do that, we're gonna send it through a heat exchanger that preheats your domestic hot water.
You're going to use the heat.
Yes.
Instead of wasting that energy,
Yes.
it's free energy.
Yes. And
That's what you were talking
This
about.
can be done for a pool or whatever.
Our clients have the option of heating up their pool for free, their hot water for free, or their basement,
So wait
or
a
their basement
second.
slab for free.
So when you get a geothermal system, you're getting two. One for your boiler and one for the main building.
There's even triple functions units. We have
triple
units,
functions. Okay,
we
I
have
get
units
this.
that will do forced air. It will do hydronic. It will do your domestic hot water. It will do cooling. It will do everything
Okay, let's
within one chassis.
Let's go back a second. What energy can we use to run this system? Let's start with that. Can
What
we
energy
use-
are we using?
Obviously, we're using electricity. We're running a compressor. We're running motors. But for every 1 kilowatt we're getting 4 free kilowatts out of the earth.
So it's 3 times more efficient.
Essentially 5 times, because you're using 1 kilowatt. In total, you're getting 5. You're getting 5 units of energy, but you're only consuming 1.
From the same amount of energy to run an HVAC system.
This is comparing to electrical.
Okay. And it's the same across the board with natural gas, propane.
Propane is probably even worse. We're probably even more competitive with propane. Natural gas is closer. Natural gas makes a lot more sense in the city because of the vertical drilling aspect of the installation. But if you're up north and you're on propane or you're on electrical, you should really consider geothermal.
So what city in this world is leading geothermal? Who's actually doing a lot of good in geothermal?
It's got to be somewhere in Germany. I think.
I was going to say it's not North America.
It's always the Germans.
You need to be careful when saying geothermal.
Why?
Because if you go to Iceland, for example, they have real geothermal.
What's real geothermal?
They drill into the earth and they get just steam. They get so much steam and energy. They can produce electricity from that. They make steam generation electricity plants from their vertical drills. In Iceland, they have heated sidewalks and streets. That's how much energy they have.
Free.
Pretty much coming from the ground.
Is it
Wow.
the mass that makes this so efficient? Like creating mass? Is that's what's making geothermal so efficient?
What's efficient is using the earth because it's a constant temperature, it's stable, and it's like just the temperatures are perfect for this application. And also what Roman says, you get the free energy.
You're not creating
it's
energy.
mind-blowing.
You're not combusting anything. You're just moving energy from one place to another.
Yeah,
That's all
and the
you're
heat
doing.
pumps just do a super efficient job doing that.
What I do know is in mechanical, and you do HVAC, so water pumps typically draw the most energy out of all parts of a home, right? For power, especially the first original startup. Like when you start a pump up, it takes a lot of power to start it up.
All motors take power.
I think I know what you mean. The initial draw, the first couple of seconds to start a motor.
So is it more efficient running water in a loop? Is that how it's helping the geothermal?
Yes, because Manny, you've done a really nice project in Toronto doing a radiant heat. Water is more dense than air. Therefore, you can transfer more energy using water as the medium.
Okay.
In a traditional gas-fired furnace system, you're heating air, you're moving it at a high temperature through ductwork.
There's more effort to heat it, to move it.
Yes, what's a 14 by 8 duct can transfer as much heat as a 3/4 inch PEX pipe. So in geothermal, we're using water as the
Wait,
conductor.
say that again. So you're saying a 14 by what duct
14 by 8 duct.
is equivalent to a 3/4 PEX pipe?
Yeah, that's how much
Copper.
Copper.
water. Okay, a 3/4 inch water line. Generally, you'll move the same amount of energy through those two.
Okay, now I get
So
it.
water is just denser than air.
So geothermal is like spray foam.
No, don't bring spray foam into this
I
mix.
want to know. I want to know.
No,
how.
well, because if you're just pushing air and you stop heating a zone, it starts to dissipate right away. If you're pushing water, it's going to hold mass and it's going to have like a memory and it's going to give energy for a longer amount of time, right?
In a way, yeah. But
Yes, and
it's a
it
little
holds more energy and it gives more energy. It's just a much
It
better
has
way
a
of doing
much
things.
higher transfer rate. You're able to transfer that energy much more efficiently.
And that's the efficiency of geothermal.
Using water sources.
Water
that's just
source.
that's just a fact. Air versus water.
That's all it is. Okay. Wow.
Okay, so let's talk commercial and then we'll go back to residential because I think.
Well, hang on. We need to take a break because we have to do a little building code
Oh.
halfway through.
Oh, wait a second.
Do you guys know about the building code 2030 net zero?
2030.
Yeah,
Yeah, I know about that. It's 2030.
it's
Yeah.
far.
Yeah,
But
and I
people are
guarantee
jumping
you,
on board.
and I guarantee you, I'm not a politician. Watch that date move.
You think so?
Watch that date move. Just watch it move.
I think it's going to start already.
You're going to see a big hand from the sky come down and take that calendar and slide it to like 2060. They're going to move it.
Well,
man.
our building at Alliance Avenue is already there.
No, everybody that's doing it, they're doing it not because they're being mandated by the government to do it. They're doing it because they're seeing the value down the road. The government never sees the value down the road. Otherwise, we would have an efficient city. We don't even have I would have to say, I can't even compare our city to like a forced air system. Our city is like a couple of twigs that are trying to make smoke. You know what I mean? They're not efficient, the city. So I've heard of that date. It's not going to happen. Good luck on it. I mean, that's just my opinion.
Why? What do you think about that?
Well, I think if it comes around, geothermal is going to be the go-to heating and cooling system.
I would love to see that. Honestly, I would love to see that. Tell that to all the people that live in $3 million homes that are 2,000 square feet downtown core right now, and you ask them to rip up all the roads to do the loops.
It's going to go for new construction, obviously. They're not going to do that for old homes.
It's going to hit new construction and retrofitting of existing large commercial buildings.
Hang on, we got to get back to this building code thing. We're getting into a rhythm now with podcasts.
Hang on a second. I know what Manny wants. Building code talk.
We just wanted to share part of the building code, which is section, I can't remember the section. I think it's section 1 or it could be 2. 6.2.3.17 of tape. Tape used for sealing joints in air ducts, plenums, and other parts of the air duct system shall meet the flame-resistant requirements for fabric in CAN/ULC S109, a flame test of flame-resistant fabrics and films. Does that make sense to you guys? You need to use flame-resistant tape.
Yes.
Perfect. That's all we wanted to share.
So basically, foil tape. Everyone should be doing it.
But that sounded more legit.
Yeah.
All right. That's all
Okay,
I'm
so
saying.
I'm going to dumb it down. Basically, when you're running rigid duct lines, you should be. There's two things you should be doing. You should be either foil taping it as a minimum,
Yes.
or at least you should be taping and putting around every joint. That's the proper way to do things. That way you have a proper source to where you want the heat or cold to go.
That's right.
Thank you, Manny,
The metal joints.
for building code talk.
Okay, back to geothermal with the professors here. This is like class, man.
I'm actually a doctor.
Are you a doctor, really?
I'm a heating doctor.
You're a he's a doctor, but we won't get into that. Something to do with proctology.
I promoted myself to doctor when I redesigned my business card.
You know what? I know a lot of guys that put that title on.
Wouldn't it? It would be really cool. Honestly, it would be really cool to see a subdivision made and all geothermal.
There's a few of those out there.
Where in Canada?
I've seen videos in the States. I'm not sure about Canada.
And
But
Canada,
they're doing
yes.
condos. They're doing condos in Canada. They're doing like condo complexes, geothermal.
And what's really cool, if you want to be on the topic of efficiency, they're building complexes with one heating source. So it's like all the units they share. There's a term for it.
So this makes this is what I wanted to get to. I mean, I love commercial and I want to get back to the commercial, but you said a few times we shouldn't be talking about money when we talk about geothermal. It's about giving back in the right places. When it comes to residential, you just made a really good point. Unless you can really afford and you're trying to make a difference in the world, that's when you should be doing it residentially, right? But when you get into mass, few townhouses or a complex, now you're getting into something very interesting because now instead of doing one, you're doing 30 or 40 homes with the same system.
Correct. Instead of having, if you have 30 homes, you have 30 oversized furnaces. Instead of having that, you have one system. It's called something. It's like a common power plant or something like that. I forget.
I think
the
you
term.
guys are wrong. You should be talking about money.
Okay, let's talk about
him too.
Listen, I agree with
talk
him.
about money then.
I think I think it costs a lot of money, but I think the benefits outweigh the costs.
Okay, I'll share an example. We finished a custom home 3.5 years ago, 6,000 square foot addition out in Caledon.
Addition?
6,000 square foot addition. I love it.
Yeah, it was nice. We installed a very efficient heating system, radiant, air handlers, a nice boiler. I tried my hardest.
Nice. I'm sure you did an amazing job.
You know it. And so what I'm getting at, I go to their house every 6 months for scheduled maintenance, and sometimes I ask them, so how much are you paying for propane? Because they love to talk about it. Propane costs them about I want to say roughly between $7,000 to $10,000 a winter.
Ouch.
Is that with geothermal? Without geothermal?
No.
That's using propane to fire up a boiler using a radiant heating system.
radiant heat.
You're just burning money if you're running out of propane.
Yeah, so it costs less in the beginning, but then you're dumping 10 grand a winter into this home, and then all year to run the boiler to heat your domestic hot water.
Okay, so that same house scenario, if we were to do geothermal, what would it cost?
It would cost a lot. I'm not going to get into the numbers. There's a lot of details. You can't just say geothermal. Are we going to, same thing, are we going to go forced air? Are we going to go radiant? Are we going to go horizontal loop? Are we going to go vertical loop? There's a lot of variables involved.
So you go radiant. You guys already spent the money on the radiant, so 6,000 square foot house, and now you want to do, instead of propane, you do geo. How much more money are we adding to that if we go geo?
Okay, Manny, listen, it's going to cost more.
But what's the more?
It's going to cost more, but
Probably
we
not
have
more than 25% extra, but that's mostly because of your loop.
But that's not a lot more.
It's not a lot
But
more.
that's
That's why, in my opinion, if you plan to own a property for a good length of time, you should be considering geothermal. If you plan to sell it, if you plan to make money on it, if you're not sure how long you're going to be there,
No, you don't.
whatever. But if you plan to keep it, if it's a commercial building, especially libraries, schools, these things are going to stay there. The same people are going to own them for many, many decades. Why are you not geothermal?
And we have a client up in Stouffville with a 10,000 square foot home. It's very nice, and he pays $400 a year for his heating.
Because it's geothermal.
Yes.
It's
And his hot water is for free.
And he has a backup boiler.
And his pool is heated for free.
Most likely, yeah. His pool, is his pool heated?
Yep, it's heated off the geothermal.
Okay,
He
so
pays $400 a year on
Yeah.
a 10,000 square foot house?
Yeah, and then he built a 20-story condo also using geothermal.
I'm
And
going
the
there
house-
tomorrow.
The house is radiant? The house is radiant?
The house has 3 water-to-water source heat pumps, and it's fully radiant throughout. And then it has 2 air handlers that are supplied by the radiant hot water. It has a water coil. It's 2 air handlers with a water coil, so the same water that's going into the floors is also going to these air handlers.
Okay, so then when they're talking to clients, because that sounds like a smart client, the propane client doesn't, like, he's not thinking long term. 10,000, 400, right? Like, how do you sell this to clients? Do they have to be tree huggers? Or they just,
No.
they have to be very wealthy because they've saved a lot of money?
What I find is most of these people are just really smart and they know what they want.
That's all it is. They've done their homework.
They know what they
A
want.
lot of homework.
Yeah.
well, let's get back to that 25%. So you're taking a 6,000 square foot addition. It's 25% more to change it over to geothermal. Within
I
seven,
wouldn't say change it.
It's
I'd
not-
say if we're installing it
To add
initially,
on.
If we're going to do one versus the other, you're looking at a 25% price difference in most cases.
7 years, it will have paid itself off, and now
I think that refers to the 25%, so it legalizes at that point. So
In about 7 years?
yeah, but your loop 5 to 7 years. It really depends on the case. Sometimes it could be less. In commercial, it could be as much as 2 to 3 years because they're using their stuff so much.
But here's the real question. You tree hugger, you. I'm looking at Carlito. What's the reduction on the carbon footprint from not going gas versus the geothermal?
That's massive.
It's huge, right?
So let's talk about those points.
Okay, guys. Well, I'm going to talk about it. So in 2015, there's a meeting called the Paris Agreement, where a bunch of countries agreed to reduce their carbon emissions. Canada said we're going to do it by 2030. I know, but guys, we have something to cheer for. We have 10 more years to go, and
We'll almost be 60.
that's okay. This is an initiative, and once you start nerding out and actually watching these videos on YouTube that no one watches, but they're actually super informative about all these building retrofits that are doing this, we are doing a super good job. And if you look at us in Lake Ontario and all the water systems that we have there, we're doing really good. We are being very competitive, and some countries have already backed out, but we know like Canada's staying in. We're not backing out.
Are we across the board, or is it just Ontario? I'm assuming Vancouver's probably just as good.
Oh yeah, geothermal is quite prevalent in Vancouver.
That's what I
They have
figured.
quite a few condos out there that are geothermal.
That's what I figured.
To answer your question about the carbon, yes, I've traveled Germany a couple times now, and there's a big thing to reduce the carbon emissions. And when you're burning natural gas and propane, you are emitting a lot of carbon into the air. And by using geothermal, the only energy that we're using is a little bit of electricity. And now with new technology on circulators, it's like we're not using incandescent lights anymore. We're using LED, right? So we have that equivalent in circulators. So yes, we're running electricity, but Ontario is actually doing really good on having green energy. 50% of our energy is nuclear. And if you look at a pie chart, where we get our electricity is really good. We are doing a good job.
Okay.
Well, what I do like at a green level is that we're typically talking about residential 70% of the time on our podcast, but this is making a really good point. The city is growing. We're not building houses anymore. We're going up. We're building high-rise buildings. We're building large factories. People aren't building the same homes as they used to. Not everyone has that option anymore because the land's not there. The jobs aren't in the same places as the land. You have to travel farther, which is a higher footprint. Now that we're getting into a commercial end and you guys are saving energy in a smaller footprint on the whole planet, this is very, very efficient for our future. So even if you don't put this in your house, people listening that are building buildings or apartment buildings, they should be jumping on board because they're going to make a difference for our kids and the planet.
It allows for sustainable building. If you couple geothermal with some solar panels, some good insulation, your building can actually produce more energy than it uses.
Here's a question for you guys, if you guys have done your homework. You remember, what was it, about a decade ago, maybe 15 years ago, the whole city place bullshit in Toronto, where basically they popped 24 towers, condo towers off of Spadina, one exit.
With a very poor infrastructure?
Yeah, so they just did that because they're stupid. Are any of those towers or any of the new towers that are going up, are they geothermal?
Plenty of them, yeah.
A lot of them are, yeah.
Really?
Wow.
Are they?
Yeah.
Are they really, huh?
Yeah.
So why
There's been a big movement towards it.
so all those
It's
towers...
happening, and so little people know. I'm really puzzled by why it's not talked about more.
Yeah.
So many community centers in Toronto are geothermal. There's a condo going up right now, I think, Yonge and something, right in the middle of downtown, and it's a condo building, and they messed up. They didn't do the loop before they put the structure up. So now what they're doing is they're doing directional. They're doing the scheduling issues.
Okay.
Now they're doing directional boarding. So this condo, its loop goes under the city's streets, under other buildings. It's all up in there,
Oh my God, what a spaghetti factory.
pretty much.
Wow.
So I didn't know that. That's interesting that a lot of these towers are already geo.
It's surprising, Manny. The more and more I learn about this, it's all over the place. There's very little awareness about this.
How do we make this more attractive for people? Okay, so in 30 years, I've only been part of 2 geothermal builds. One in the United States and one here in Canada. Every time I talk to people about geothermal, they don't want to hear about it or they don't want to talk about it. They just don't understand it. It's too difficult. How do we make this sexier or more drawing to people to start using
There's
it?
a real lack of experts in the field, and a lot of the stuff that's being built doesn't work the way it's intended to work, and that's a big problem. We need more experts.
Where's the fault?
We need more education. We need people mentoring people, just like we've been following Denis for the last year or so. There's not enough knowledge out there. There's not enough qualified installers out there. People don't know how to size things properly. You need a really good engineering team to do a proper building. You can't just come in there, put a loop, this and this. Things won't work the way you intend. You'll be working like 70% of the year, and other times you can't keep up. Or if you oversize your loop, you'll put so much heat back into the loop, you're going to have a problem. All your compressors are going to go on overheat.
Yeah, guys, and you know what? I want to bring this up. Geothermal in the last 20 to 30 years has gained a really bad reputation.
Why?
It has because of poor installation. Poor installation.
Is it poor installation or is it poor design?
Both. It really is an engineering task.
People just want to make their money. They just want to sell it, do something, get out of there. And then somebody's stuck with a shitty product and they're spreading a bad word about geothermal.
Yeah, and it doesn't work. And I've been to houses like this where they ripped out the geothermal and they put in a boiler natural gas.
What?
Really?
Yeah, because the ground loop was undersized. Our competitors, they love to use coils that meet the minimum requirement. See, in Polar Bear, we use bigger coils, thicker copper. Our units will last a long time. The geothermal industry, a lot of previous installations where engineers, contractors, they were learning, making mistakes, and unfortunately, a lot of systems were undersized.
A lot of these companies were gone. People have gone out of business, and now people are stuck with old systems that have motherboards from a particular company. That company's not even around anymore. How do you fix this?
Can't fix it anymore.
We don't have motherboards in our systems.
So going back to what you said before, if you're cheap and you're undercutting a geothermal system, it's going to suffer.
You're gonna lose.
That's right.
What is the formula here? Like, is there a basic formula and you guys look at the square footage of a building and what size pipe you're supposed to be using, drilling? Is there, like, it feels like you need designers and scientists
You
working
need
together.
engineers involved in every project.
That's what you need.
You got it.
And so you guys have engineers that know
Yes.
exactly based on the size. Now, the building hasn't, okay, you guys are talking about new construction. The building hasn't been built yet. And I've always find this really fascinating with HVAC, mechanical. You guys are designing a system for a structure that's not built yet.
Yes.
So there is a little bit of trial and error on how the air is going to move. You're doing it based off of drawings, right? And on cubic size of rooms and everything like that. So then you determine what size furnace, what size ductwork, what size everything. It's the same thing with geothermal, right?
For sure.
So you're looking at drawings of a structure and you need to figure out what do we really need, what size to go
We
with.
have to be involved early, and we gotta tell them the space we need. We gotta work with what insulation is going to be used. If things aren't sized properly, everything's going to go to shits.
And you only get one shot at that sizing. The drilling, the loop is one.
Sometimes you can be lucky. Maybe you're not so far off. Maybe you can add some loop, but you're just looking at more costs.
Yeah, and you're working with a lot of money.
Okay.
So we got that one building, the same client, the one in Stouffville with the 10,000 square foot home. He's got a condo in Oshawa. He built a condo, I think it's like 17 stories or something. And he did geothermal, and he didn't go with us for his equipment for the condo. He went with another company. And now he's experiencing so much issues. He's had so many HVAC contractors there, none of them can fix it. So we've been brought in, and we're charging him ridiculous amounts of money, but we're bringing things up to par finally.
What's the issue? The issue is that they're not heating and cooling the way it should be?
The issue is poor equipment. The issue is the loop is overheating.
Is that because of spacing or not enough of them to
Not
cool?
enough heat is being removed from the loop because the building is cool dominant.
Wherever you're trying to release the heat, it's staying too warm and it's not cool. It's not cooling
Just not
down.
enough. Not enough people are calling for heat.
Let me give you guys a scenario.
Dum dum dum.
Can we geothermal a shed? Does everything downsize? Does it downsize? Does it do that? Can you go in my backyard?
Yeah, we can do a tiny heat pump, small loop.
The answer is yes.
You can do it. So everything is downsized, right?
Yes.
And so you have a smaller heat pump and you have a smaller loop or smaller pipe, everything, and then you can heat that structure.
Yes.
Okay, I was just curious.
From what I understand, the biggest problem in geothermal is the grid should be laid out first, which is the cooling system. That should be done before the
You
building
mean the loop.
structure.
You
That's
mean the
right.
heat exchanger.
The loop is the most important part of geothermal.
It's one of the major
There's
system
three
components.
parts, like I said. You have the heat pump, and that's right bang in the middle, and that works with everything else. It's connected to the loop on one side, it's connected to the building on the other side, and it allows energy transfer between the two, which is also reversible depending on the season.
Are you guys working with any of our Ontario housing projects to kind of save taxpayers' money with the government? Are we doing this? If we're trying to make that 2030, shouldn't we be doing that in like welfare homes and like co-op buildings? And
There's not enough of this happening. There used to be some really nice rebates for geothermal a couple of 10 years ago, 15 years ago. Those are all gone all over Canada. The States is giving 30% money back on your geothermal system. I don't know why we're not doing it here.
Across the states?
All across the States.
30%?
30%.
And guys, by the way, there is one geothermal system being installed in the States every day.
And in Canada?
If not more. It's going to be more than that. Canada.
That's an old statistic, but one system a day in the States.
let's get to Canada. What is the best system for a soil area, and what is the best system for a rock area? Or does it matter?
It doesn't matter because you guys said earlier
Well, no,
on,
there's a cost efficiency,
they
right?
can drill through.
I believe rock allows for more energy transfer.
And
Sand is trouble. Sand is no good.
Why?
Rock is just poor energy transfer.
That's all it is.
So if we were down here at the beaches, you would say that we would have to tie into the water lines so to cool the
Water
systems.
is the best. You could do a lake loop. You don't need to use the earth. You could take your pipes and you can sink them at the bottom of the lake with weights, and you could remove energy from the bottom of the lake all year around, and you can dump energy back in there in the summer.
Say I'm at Bathurst and Bloor. What is it that you would sell to me?
Natural gas.
Natural gas. And the loop system would be what?
I'll tell you a Mitsubishi Mr. Slim.
By the way, I like them.
I hate them. They look like shit. I don't care how quiet they
So
are.
before you even vertical drill, you need to do a sample. You take a core sample and you send it to the lab, and the lab comes back with the results to tell you, and then you take it from there.
The results of what? How much energy there is in that sample?
You get the results of what kind of soil, what is it, rock, is it sand, what is in the ground there.
In order to size your loop, you got to know what your heat transfer rate with that particular soil is.
So
If
you
it's
know
higher
how
or
big it
lower.
is.
So you know how much you need.
Okay.
And it doesn't change from 6 feet below. It doesn't change. It's relatively the same kind of.
Relatively. All you really need is 5-6 feet.
And it costs
As long as-
$22 a foot to drill.
As long as you have horizontal
$2?
space, you can forget
$22
the
a
drilling.
foot.
But if you're in the city, you can't. You don't have that option, unfortunately.
Okay, so for our contractors, our GCs, and our homeowners, what is the stopping point that's not realistic to do geothermal in a home?
If you have a home that's too small,
And what would that, in square feet, what would that be? Say I have a customer that has a home at 3,000 square feet. Unless they're really trying to make a big difference and they're planning to sell the home to another family that would continue on with being green, what would that square feet be? Just so that listeners can pay attention to that. Because I think it's very important that the listeners understand that at a commercial level or at a very large level, this is very efficient. And this is where the bang for your buck is.
It's still very efficient on the residential scale. It's just, does the customer want that? Are they going to stay in that building for a long time? Most people, they don't live in a house for a very long time. That's why they're not doing it.
Are you living in a house or a condo?
I live in a townhouse.
Okay, so I guess you don't have geothermal there. But if you had a choice and you were in Ontario, what would you do?
If I had a house and I say I built a house, I would do geothermal and I would keep it for 30, 40 years. And I would save money. If I'm up north and I build a cottage and my options are propane and electric, I'm going to do geothermal. I don't want to spend all this money on utilities.
Right now I'm going to use my example. No, because this is going to help me because I'm at a point where I'm going to be knocking down my house right now and building a new home. You guys sell me on what kind of system I should have. I'm 2,000 square feet. I'm on slate on basically a hill, and I have like 1,000 square feet of waterfront or 1,000 linear feet of waterfront. Lake Ontario. What are you selling to me, and why do I want to go that direction?
You have the most economical potential for a geothermal system because of the lake. The cheapest way to get a geothermal system is a lake loop, because you don't have to excavate, barely, maybe a little bit to get into the lake. You don't need to drill.
Okay, so my problem is, and I'm going to stop you there because I have a really serious problem. I have conservation on my waterfront. I can do anything in the water, but I can't break my ground. Like where my beach meets the water, I'm not allowed to touch that at all. I can't dig there. So what is it around? How do I get around the conservation part of it? Because I love that. And I really want to, like this house I'm building, it's going to last me till I'm dead.
I'm sure there's a way. You find a way to insulate that pipe, or
Can't you just
you
drill
do it? You do it, and you do it at night, and no one ever knows.
Okay, I can't do that. Bribes. So basically, I'm on an island. That's what I live. Like my house is an island. Mm-hmm. It's very protected. Like conservation, they don't joke around.
I'm not 100% on this, but I believe a lot of these conservation areas allow for geothermal.
Okay, that's good to know then. So I'm going to look into that. How much is it going to cost me to do a 2,000 square foot? Let's just say it's at 2,000 square feet right now. How much is it going to cost me to do a complete system with you guys?
Ballpark. We won't hold it to you, but everybody listening will.
And how much would I be saving if I didn't go geothermal, but not save in the long run?
If you do a lake loop, you're really going to be really close. You're not going to really pay a premium.
Okay. A system from the beginning to finished typically cost?
There's so many variables. Again, I don't want to be making up numbers because there's so many variables. Do you have a pool? Like I said, is it forced air? Is it hydronic?
Well,
do you have a triple,
lake.
Or do you have a triple function? There's a lot of variables. How good is your insulation? There's a lot of factors. If somebody's really interested and wants to find out,
well, I'm very interested right now.
So you want to talk to us?
Let's break it
down. You want to break down the details.
Like I'm actually a customer right now. I'm actually asking you guys because I'm very interested. And after this podcast, I want to talk to you a little bit.
Okay, so let's break it down.
We should really connect with an engineer at that point.
Okay.
And let's get them to assess your property and the earth and the loop. And then we can talk numbers.
You guys can't give up a price just yet because you don't have something that's comparable to that scenario?
We've only been doing this for just over a year. We have a guy with 30 years of experience behind us. He's been building these things for 30 years and installing the whole
residential.
No, that's fair. I respect that. I
don't want to be giving you false numbers. I don't want to be giving your listeners false numbers. If somebody's interested, we could have a serious conversation and we can give you numbers.
I can give you a BlackRock HVAC price of $100,000.
For the Geo?
It's on sale. Carlito.
Are you just making that up?
I'm making that up.
This guy thinks I got $100,000 laying around.
Well, in all fairness, man, a radiant system boiler for 2,000 square feet is going to cost you $70,000.
I'll tell you about the heat pump. You're looking between $7,000 to $15,000, depending how serious you want that thing to be. What do you want? Do you want to have every possible function, or do you just want?
What are the functions? Let's go over a few of them.
There's different units. There's certain units that are just water to water, and they will just do hydronic. There's units that are just water to air, and they will just do forced air. There's units that will do both. There's units that would have the add-on option of the desuperheater, allowing for domestic hot water.
You have to do both if you want AC and heating, don't you? You got to use the heating for the water for radiant, and then you got to use a forced air system to run the...
It's one unit.
All of them give you heating and cooling.
Oh, really? You're just branching it off.
So you get a water to water and you want cooling. How are you going to do that? Well, you add an air handler.
And then you connect it to the ductwork and run it all there.
Exactly. So with a heat pump, it just looks like a furnace, but much bigger. It's a bigger box connected to ductwork. And there's no units outside, nothing. It's just a box in your mechanical room. Not
necessarily to ductwork. I changed the compressor on a unit last week. It was a 20-year-old unit. And it's still kicking. I just had to change the compressor on it. It finally died. It's doing all the in-floor in the house. It's doing the pool in the building. And it's got an air handler upstairs. It's feeding water to.
Very versatile, all these things. You can do anything you want with them.
But like you guys said, that if people are doing it incorrectly and then there's a problem where it's not sizing the solutions for the heating.
The big problem is often in the heat pump quality itself and also in the quality of the loop people install for you.
And when you say the quality of the loop, the actual pipe itself is not a lower quality?
Sometimes people don't have the experience and things go wrong and maybe there's a leak in the pipe, maybe things get kinked.
Or you don't make enough loops. In construction, we both know, it's very easy to
Minimum code things.
Minimum code, and you want to take shortcuts, save some money. You know, it's really easy to save money with making less loops or
Well, this is a great point. So where should you never cut corners?
don't cut corners.
Well, people are going to ask to do
don't
this.
cut
so-
corners with your earth loop.
Okay.
That's the worst mistake you will ever make.
Because that's basically the foundation of the
If you
whole
get
system.
that right and you get a poor heat pump, you can still replace the heat pump. The loop is there. And if you did it right, it's there for hundreds of years. And you can
Okay.
replace your heat pumps as you go. But the loop is there, and you can use it for as long as you want.
So-
It will outlive you and your kids and your grandchildren.
Say right now, I want to spend my money wisely on the loop system. I can go a little cheaper on the second part of it. And then as I get some money, I can replace it and get into a better...
No, that's another mistake you're gonna make.
You're going to spend more
Just
money
do
if
it,
you
do
do
it
that.
first.
You just gotta-
Ideally, you want to do it right the first time, and you never want to call us for a long time.
Are there municipal issues regarding digging? Because you're obviously digging under people's other like properties, and you're digging under public property. We have to fill out forms, and there's a bunch of red flags.
There's a team of designers and engineers involved even before we arrive that take care of all of that.
That is a part of the formality.
Yeah, for
that-
sure.
that
There's,
you
there's
have-
all kinds of things in the earth you got to watch out for.
Yeah, you can't just start
Absolutely.
digging loops and
Absolutely.
Okay.
And Carlito, back to your point.
You have to analyze all these things before you go ahead with the project.
I want to add to Mr. Pavlovich's point.
I love this guy. He's so
about-
official. I feel like I'm in the military. Whenever someone uses my last name, it's like military.
For the police.
Sergeant Orest.
Imagine we're building a hot rod and you restore the body, you wrap the seats in in leather you like with the cross stitching that you love, and you get an engine, you put the engine in, nice braided lines in the engine bay, and then you cheap out on the radiator. It's too small. What are you
It's
gonna?
constantly overheating.
Yeah, and that's bullshit.
Yeah.
Now you can't even
Drive my car
You can't even enjoy the
efficiently.
damn car.
Yeah. Okay.
So you're gonna undersize the loop. You won't enjoy your house. It's gonna be a constant headache.
How many companies are out there in Ontario, geothermal wise? Is there a lot?
We're the only manufacturer in Ontario.
Okay.
We do total engineering, design, manufacturing, and installation. There are plenty of contractors out there, but we are
A lot of them are using American equipment. And
Yes.
It's very, very inferior in many ways.
So you're saying German technology.
Canadian.
Canadian.
Oh, I like that even better.
This is a local product. But
I like
we
it.
We are one of two branded water source heat pump manufacturers in Canada.
What is the maintenance that you guys are actually doing yearly? You said every 6 months you guys come in. What is it that you're looking for? What is the maintenance every 6 months?
So it's a refrigeration system. So you come in, you check the pressure levels of the refrigerant, you check the oil, you check if there's acid in the system. You test all the ball valves, open and close, and make sure nothing is seized. A very detailed visual inspection, temperature checks. And just you go in there and make sure it's working and the customer's happy.
I got a question for you, gentlemen. What if you guys come in, you guys design everything, engineer everything, set everything up, build everything, give me a quote, I sign off, do not ask for a discount, and then we start the system and it's not working properly? Who is at fault, and are you guys expecting me to pay more to figure out this system?
If that does happen and it is our fault, we will take full responsibility for it. Not that it's happened before in the past.
That's what it sounds like. You guys are saying that geothermal's got a bad rap because guys,
people aren't doing it right.
They're not doing it
And
correctly.
it still works.
Because
People do it, it still works.
If I had the money,
Systems die 3-4 years into it. They're not getting heat on the coldest days. They're on emergency heat on the coldest days of the year. It still works though. Look,
no, but I'm saying is that
recently-
if when I don't know a part of construction, I don't dictate where it's going to go. When a mechanical person comes in and they start dictating how this should be, and you present everything to me, and you guys know the structure, but then the system is not working correctly, I'm going to be a little upset because I never argued or contested what you guys said to do.
Look, I believe the contractor should take full responsibility of their product. They need to stand behind their promise. And if something doesn't work, you go in there and it's your responsibility to make it work.
But that's not the industry that we all know. Just saying. So that's all. Okay.
So let us be an example to other contractors. Let me tell you about an interesting thing that happened when we installed a system recently in Markham. So there was a house. They were already on Geo for many, many years. Their heat pump died. We came in there with a Polar Bear unit. We cut out their old heat pump. We connected everything. They had a second heat pump. There was two. So we replaced one of them. You know what happened when we connected our heat pump to the system? It killed the other heat pump.
Why?
Because we were pulling so much energy out of the earth, it caused the other heat pump to freeze up.
So you guys had to replace that one
No, it wasn't needed. We were able to pull the whole house with the one.
with the one.
Yeah.
Our heat pumps are nice. Like if it's an engine, it's a V8 for sure. You don't need to put a lot of effort into pressing the gas pedal. It just kind of goes with little effort.
Sounds like a diesel motor.
You know what? In all fairness, I'm still on the fence. If I had the money, I'm still on the fence because
Do
of
your
the
research.
concern.
Yeah, for sure. If you're considering these things, you want to know. You want to know everything. You want to know all the concerns, and you want to make sure you mitigate everything going wrong.
Because I would love to have that house with geothermal and tell people, yeah, my heating
We've
is
got so many.
$400.
We've seen so many of these houses now in the last year, and people have systems that are 20 years old, and they're happy.
Yeah, they're all happy.
They're
So
comfortable.
what fails? Just the heat pump fails.
The thing that fails that we're usually up there replacing is the compressor, and that's usually 15, 16, 17,
Yeah,
20
and
years.
they have a life expectancy of 15 to 20 years.
That's normal.
Is that a big
Which is
ticket?
It's better than replacing the whole heat pump.
Our heat pumps are rebuildable. The chassis will last 100 years. You go in there and any technician can replace all the components. And we don't have any proprietary parts. We don't have any circuit boards. We just have your basic contactors, relays. And over the last 30 years, only 4 relays have ever failed. So our parts are oversized, wiring is oversized, coils are oversized, everything just solid
We're going above, and we're there to protect the customer.
and make a point.
So who doesn't like you guys? Hydro?
No, Hydro love us because we use electricity.
But not to the extent that
They love us.
How?
They want us to install more systems.
Is it because that we have such a shortage of power, and they want to try to stretch that out, and you guys
No,
are helping
we have
them get
expensive
their power?
power.
They're in the
Here.
business of selling power. They want to sell power.
Yeah.
So who doesn't love us, Roman?
That's an interesting question. I don't know.
Well, everything that's
Polar Bear
good.
haters, they should die.
What,
How do you
sir?
not love a polar bear, man?
Yeah, I know, right?
What was
That's
that?
true. There's not going to be any left soon if we don't start using geothermal.
There's always somebody that dislikes you if you're doing something better because you're putting them out of business.
cheap folks. Cheap folks that don't want to spend the money, that want a cheaper option, and we're just not there for them.
You got a really good point about, I've heard you say it a few times now on the show. People don't want to live in that same house for a long time. And that's because the house wasn't built properly. But if the house was built properly, they'd stay.
Yeah.
How do you have Europe like that? How many
But-
people, like generations, live in the same house over and over?
Gets passed on.
Gets passed on. And that house is not falling apart. I can only imagine the same as in Germany and Geneva, whatever, right?
I don't know. In Croatia, we built out of concrete, so nothing's really falling apart unless you send a rocket over there or something.
Guys, you know who doesn't like us? People who don't know about this. I was there. 2 years ago. I was that HVAC guy who didn't know anything about geothermal. And when Roman calls me, he's like, "Hey man, what do you think about geo?" Screw geo.
Why'd you say that?
It is a complex thing.
Yeah.
I didn't know anything about it. I didn't take the time to study or research it. So if you don't know, you don't like.
Do you have geothermal in your home?
I do not have natural gas.
Okay. And what's holding you back from doing geothermal in your place right now?
Waste of money.
It's a detached home in Mississauga. I'm not gonna drill vertical loops in my driveway.
So I guess the next when you get to that custom home, you'll be definitely doing that then.
I would love to have a geothermal system, radiant heat throughout. These things have a backup electrical heater just in case. And in our systems, they never even work.
That is very important. What you just said that like sticks out to me. I'm like when we talk about water tanks and water on demand. That's like for me a water on demand is very dangerous area for me. So you're saying that having a backup that's something that is a potential problem for the future that you should have a backup in.
Most geothermal heat pumps have an electrical element as backup heat. And on the crappy systems that we've been talking about, they tend to run a lot during the winter. In our systems, they don't. They run maybe once a year. Just
If something happens, the backup is there. Say your compressor dies and you can't get a technician out there for a couple days to replace it. You're still comfortable. You're not worried. You're not freezing. Your water pipes aren't freezing.
Is it easy for a homeowner to take care of this, or a high-rise building? Is it easy for maintenance to be able to handle it without calling you guys?
Very easy.
It's pretty well stupid. Like you have to be really.
Most of our clients never call us until something goes tragically bad, like a compressor.
It's good to hear.
And we have client parties in the summer too. And these people are clients from 25, 30 years ago. Yeah, they're old folks. Old folks, they still come out.
They're fans.
Smart ones.
And they're happy.
And they have really funny stories to share, but they still love the Polar Bear geothermal system. And that's why we're still here.
Let me tell you a cool
learning
story
this.
about backups. So Dennis did this one project he talked to me about. He did a storage facility somewhere up north, and he installed a few heat pumps for their heating and cooling, and they had 2 boilers as a backup. So they're not using electric as a backup. It's cheaper to use gas as the backup if it ever happens. They had another boiler for the snow melt all around the building. So a year goes by, customer calls him, Dennis goes out there. He checks the boilers, he checks the heat pumps. The boilers have never ran. It's been a year, they haven't come on. He's very happy. He's concerned about his gas bill for the snow melt. Dennis chops out the boiler, repipes the snow melt into the existing heat pumps. Everything works off the existing heat pumps. Now he's doing snow melt and the building. He didn't even have to add a heat pump. And none of the boilers are operating.
It's a common thing in our industry to walk into a building and they have massive backup boilers with like a 2-inch gas line coming in.
Because you're expecting failures?
Engineers, again, we need more engineering here. We need more qualified people. And people design, engineers love to design things that it's over designed and they use way too much backup. That's how our industry is right now.
It's a standard in the commercial
if anything
industry.
fails, it could fall on them. So they overbuild. A lot of homes we're doing it right now are overbuilt.
No, you're right.
Oversized and overbuilt.
You are right. Now
That's
that I
a
think about
stereotype.
that.
100% it's a
Homes
stereotype.
not so much, but look at commercial building. There's 2 pumps for everything. There's multiple backups for everything.
Huge. And we're talking about like 2 million
And that's
BTU
because so
boilers
many people are
for
living
backup.
there, and people are going to start calling if things go bad. That's why the backups are there.
We tend to walk into buildings where we need to shut down the boilers. The 20-story condo, the earth loop was overheated. So we actually shut down the boiler, and now we need to reject that heat from the earth somehow.
Yeah, they thought they weren't getting enough heat from the loop, but really they were overheating their loop and killing their heat pumps.
And in the building that we're in, so major portfolio project, it's on Jane and Eglinton, we have so much energy being produced by these heat pumps just to not overheat the earth. We're doing snow melting. And we're heating the garage as well.
Wow, because you're trying to release that heat
Yes.
somewhere.
Yeah. So when we're talking about that efficiency, like how you get 4-to-1 energy, that like sometimes that 4 it's too much. You need to do something with it. So we're rejecting that heat into the sidewalks, into the ramp, going into the underground. We're heating the underground, and that's all free.
Is that something that you guys would do during the design stage with the engineer, where you just realize that? Or is that something you guys do when...
No, it was done during the design with the...
Yeah, we have some mad scientists working with us.
Sounds like it.
With physics textbooks all over their offices.
What do you want to change about geothermal?
Ooh, is that the question?
I just wish people were more aware. Nobody knew about it. They studied about it.
But there seems like there's a lot of misleading information out there.
Most people are afraid of it.
If you really want to find the good information, it's all out there. All you have to do is use Google.
You got to research. What I would change about the industry is the education. Look, when I go to Europe and I talk about geothermal, everyone already knows about it. People know about it. Oh yeah, that thing. Yeah, of course. Taking heating from the ground. Blah, blah, blah. This heat pump. Yeah. Women, men, they know about it. But you come here and it's still this mythical unicorn that people don't know about. So what I recommend is, I don't know, go to university and take physics.
Nobody's going to do that.
It's a little too much, Orest.
well, too bad, you know.
Why don't you just take some physics courses on YouTube or something?
Oh, there you go. Watch
There's
videos
this
on heat transfer.
amazing YouTube channel called Engineering Mindset.
Yeah.
And it breaks down all these principles so well, if you guys are really interested.
Engineering mindset.
Go on YouTube, watch videos on heat pumps, on lake loops, what Toronto is doing with Lake Ontario. It's fantastic.
I got to check it out. Again, what's the website for Polar?
PolarBearGeo.com.
Instagram handle?
Polar Bear Geo.
And then the YouTube channel?
Polar Bear Geo.
Everything's Polar Bear Geo.
Okay, we're getting close to
Get
wrapping
on it.
up, but we've got to do another little segment.
Oh, It's Green Book talk. All right.
What's up for Green Book today? You guys are familiar with the Green Book?
So every contractor is supposed to have a Green Book
Health and
on
safety.
site. And
that thing.
well, what we're finding is a lot of people aren't paying attention to it, so we're making it aware to them that this is something that they should be practicing every single day. Even though we're not part of their tailgate meeting, which you should hold every single day. Every contractor every morning should have a meeting with his guys about the day, what they're going to do, their safety, the weather, and so on. So this is kind of our way of sharing tail talk. Today, we're going to talk about employer failing to ensure that a competent worker is trained. So if you don't train your guys, give them WSIB and so on, for each person, it's $550 that works for you. And that's just for the employee. That's not even the actual supervisor or company owner. So for everyone that's on a construction site working under someone as an employee, and if you don't have those records to show an inspector, that's a $550 fine.
That's money that can be spent on geothermal.
Yeah.
Thanks, guys. Thanks for the lesson.
Back to geothermal. What else do we need to know about geothermal that we haven't discussed? Because we've discussed a lot.
If you're researching geothermal, look up water source.
Water source.
Water source.
Google search water source geothermal.
Yes.
And what's going to pop up? Porn? Like, what's popping up? What's going to come up? They're going to do it.
No,
People are going to go online, and I want to know.
But Manny, this is really important. You know, every time I go on Instagram, I don't watch television, but every time I go on Instagram or I flick through Facebook, I see all these young teenagers and they're doing roadblocks, save the planet. They're talking about carbon footprints. Why is the next generation educating themselves to save the planet by doing geothermal? Why can't we send that message out to them that they could be doing little things like this to change the world?
Okay, guys. All the young people out there, if you guys want to get into a trade, you want to have a specialized trade, a licensed trade, you're interested in geothermal, just start looking up water source heat pumps, start looking up what is the refrigeration cycle, what does a TX valve do, heat transfer, all that kind of mathematical physics kind of stuff. That's what's going to make them money. That's what's going to build them a great career. It's definitely going to propel them forward because that is the way our industry is moving. That's something I recommend.
So saying that, you guys must be looking for some employees. Are you guys at a happy point right now?
We have a good group right now.
What was it that you were looking for when you hired those guys?
People that take initiative.
Someone who can go home and read something and come back the next day with new knowledge.
With you, I think it's mathematics. You love math.
I wish I loved math in grade 8.
You want guys to show up on the job site with a calculator.
You know what? I want guys to take the lead. I want them to come up, do their homework. If you're a student and you come to class the next day, your teacher knows you didn't do homework. She just knows because you ask stupid questions.
It's a great point. A job should be like getting an education, right? Study and pass your courses.
Follow the leader. Don't get towed by the leader. You're going to get fired that way. And just so you know, in Polar Bear Geo, it's a small group of people right now. We have Denis, and then we have four of us, 4 young guys. We are learning underneath him. So we are looking to grow. We are growing his design team. We're growing his manufacturing team, the installation team. You know, the company is 30 years old, still relatively young. We see a bright future. We see a bright future ahead for us.
It's happening. There's a big movement. There's a lot of potential out there, and we're here to grab it.
How old are you guys?
I'm 27.
Holy cow.
30.
Okay, here's the big question. I beat Manny to it. This is a 2-part question. What tools do you guys use?
Oh, yes.
I gotta know.
I already know,
Okay.
man. I know the
It's
answer.
all the refrigeration tools, really. But
Milwaukee?
there's a lot of
Milwaukee.
interesting tools.
It's Milwaukee.
Oh, you mean brand?
Yeah.
Brand, Roman. Let's go.
It's Milwaukee.
What tools do you use, Roman?
Yeah.
Are you serious?
He's lying to me.
I have a healthy drill in my truck right now.
Beautiful. Love it.
Listen, having one drill or one
It's
brand.
better than nothing.
No. Do you have more than one?
I just got the one healthy right
Dang, he's not a healthy guy.
But
now. I
he's
got
healthy.
everything. I got Makita. I got Milwaukee. I
So
don't
what tool
discriminate.
do you have 2 of?
I got like 4 Makitas and 4 Milwaukees.
Then you're a Milwaukee Makita guy. You're not a Hilti guy.
But remember, at the beginning, there's no place. Like one thing
Am I a fine guy?
I got a
one
couple.
fine.
I got a couple of Bosch tools. I got a bunch of tools. I don't discriminate.
But I'm still going towards Makita and Milwaukee. Or
That's
what
fine.
are you?
That's fine.
Okay, I grew up with a very opinionated father,
I love this.
and I love Makita.
Good for you.
That
Right
makes
on.
sense.
For bigger drills, it's all about Makita for me. But I am a mechanical contractor, and Milwaukee does make sense for a lot of
I knew
other
it too.
things.
For sure.
Yeah.
So I spend my time with both Makita and Milwaukee.
There was something that you said many times throughout this podcast, and I really respect you for it. I was trying to play the cheap customer there, but I love that you're not allowing.
I'm not gonna waste money on you.
Yeah,
I'm not gonna waste my time on you.
This is
Sorry.
what I'm. This is what I'm. No. This is what I'm leading to is that a good contractor doesn't just accept a budget. Like you are aware that it's going to cost so much money to have an efficient.
We can help you.
System?
Like, we can give you more economical options, but it's still gonna cost more than your conventional system in almost every single case.
My point is that I respect that you're not backing down, and that makes a good contractor. A bad contractor, somebody goes in and just does it. And I think that Geothermal got a bad name from guys like that. They were just meeting the budgets and they were giving bad products. And what I respect about you guys, but you said it and you were proud about it. You were like, this isn't somewhere you're not going to spend money. You have to spend money in this. And I think that if anyone's listening, you're bang for your buck if you do it properly.
Do you guys present that to your clients?
I just wanted to say, build better, guys. And everyone that's out there, build better. Build better. And we're here to build better with better builders.
Do you guys do that part of the engineering when you guys set it up for your clients? You guys present a cost analysis of what this is going to be like 10, 20, 30 years down the line? What your savings potentially is? Or
Yeah, we could do that.
that's part of it, right? Because that's
especially if we have a serious commercial client and there's a big project involved, a lot of money on the line. It's a big building. Nobody wants to go back and fix things afterwards. We need to analyze things.
Because if I'm going to spend the money on Geo, I want to see a lot of data.
For sure.
Ooh.
That's just me.
We offer consulting services. If you're not sure, if you want to find out how it will go, and you want to maybe do some analysis, get a consultant involved, pick out some land, see what you're gonna do there. We can help you.
There is engineering involved, and you're more than welcome to come by and go through all the numbers.
Oh, yeah. That'll glaze right over me.
So
If you guys are interested, by the way, you guys seen this video? If you want to come by that building, you're also welcome to.
I definitely want to check it out.
It's a good
one
way
day.
to understand the system. You got to go there, hear it,
Crazy.
smell it, listen to it,
It's
touch
crazy.
it.
First time I walked in that mechanical room, ooh, mind blown.
It looks nice on video. In the video,
Is there, and I've heard you talking about working with contractors and but it's mostly been about engineers. What size room are you looking for to have for your mechanical room for this? Is this a large room? Because most mechanical rooms are never large. They're always small. Does this take a lot of room?
It's just a furnace. It's just about the size of a refrigerator. It's a bigger furnace.
So there is no.
If you're talking residential, if you're talking mechanical, the rooms are big anyways. There's room.
Okay.
It doesn't need to be too much bigger than a traditional mechanical room.
But don't make small mechanical rooms.
Yeah, those suck.
oh, we all are on the same page on that. Man.
It's a room, not a closet, people.
Yeah, yes,
Oh,
yes,
okay.
yes.
I have a funny feeling. I know that these guys are on your side on this, but what kind of vehicle do you guys drive?
My van, her name is Princess.
I love it.
And she's a 2015 Ford.
No way.
Ford Transit 250 diesel extended tall roof.
I thought you were a Mercedes guy.
All those
No way.
titles, all those names doesn't make it better.
Oh, mine doesn't rust.
Because you lost me at Ford. That's all I'm saying is you lost me as soon as
Don't
you
worry,
said Ford.
I have a Ford 450, so I'm on your side. And you?
I have a GMC Sierra. V8.
Yeah.
I got another V8. I also have a Mercedes E550.
Oh, there you go.
Double V8.
Well, I got a Chevy van too. So, and I have a unicorn outside. It's a 4x4, so I call it the unicorn.
You do, yes. But guys, I'd rather be driving a sports car.
Yeah, me too. But I'm not at that stage in my life yet. I was, and I had to get rid of them. They caused trouble.
Same.
I do want to know what kind of contractors you guys like working with. Like you guys mentioned it a few times, but we never really touched base on it. What kind of contractors you guys like working with? You're obviously wanting to work with good contractors. You already work with good contractors. What kind of contractors are you looking to work with?
People that are knowledgeable, and if they're not, they need to be open to learning things they don't know.
Is it always someone that's approaching you guys about geothermal as a contractor, or are you guys approaching contractors looking for you guys to build for something? For
We
them?
haven't been taking the initiative approaching people so much. Maybe we should, but we are dealing with a few contractors right now who have reached out to us.
Me personally, I like working with contractors who are willing to follow along, trust me, and learn with me. And the second type of contractor is one who's already made the mistakes. And now when he's shopping with us, he knows what to look out for. Once you made mistakes, you know what to look for, and you don't want to make that same mistake again.
That's right.
That kind of contractor sees you, and they just know. They know, and they go with you.
I just got one last question. Okay, just
Sure,
let me have-
go ahead.
I'm curious because you said the big V8. Do you got a hot rod at home?
I do not have a hot rod.
Oh,
but
I was hoping you had
I
something at home.
can't, guys. I need to hustle and bustle right now with my Fords. I daily drive 2 Fords. I don't want to be driving automatic Fords. I want to drive stick shift and get my sports car with a V8 twin turbo.
They don't make stick shift
That's what I
anymore.
want to do.
Nobody makes stick shift anymore.
Well, you got to go with
fucking paddles.
you got to go with a
What do
90s.
I want ping pong tables.
Something from the
Fucking-
90s.
Yeah,
I'm a 90s car guy.
Of course.
I am too,
Today's cars suck.
and older.
That's everything?
That was quick.
Thank you, guys.
That was quick. That was an hour and a half, man. That was quick.
That was the quickest hour and a half ever.
All right, Carlito. Oh, first, thank you very much, Roman, for all the information. Thank you
Thank
very
you for
much,
having
Orest,
us.
for all the information.
Thank
This
you.
is really enlightening. Honestly, I've learned a few things. It's still glazing over me, but I'll be listening to it
I'm
again.
pretty impressed that you said at the beginning, I don't know anything about
I'd
this.
have to say that because I don't know. I told you, I've always said that on a job site. I'm not the smartest room. I like hanging out with the smartest people
Yeah, I
because
like
then they
that.
teach me.
Ooh, I know what kids can do. Learn how refrigerators work.
Let them. And then they can go inside and close the door.
Yeah.
Process of elimination. It's time to get us out of here. That's it. Thank you very much again. Polar Bear information. www.polarbeargeo.com and then the handle Polar Bear @Polar Bear.
At Polar Bear Geo. Boom.
Boom. That's it. Thank you guys. Thank you so much. This has been great. Everyone's gonna love this one. Carlito.
416. Boom! T.O. baby! Yeah!